Hello everyone, we are Group 8 and I am Joyce and they are Becky, Wishes and Peter, and today our topic is Innovation of Energy Program. And this is our outline, and I will talk about the short question and Becky will talk about the combination of the wind energy and nuclear reactor, and Wishes will talk about the potential benefits and advantages. Lastly, Peter will talk about the diamond framework. For the short question, it is why Australia can promote the use of nuclear energy. The answer is that the Australia has the world's largest uranium reserves to support nuclear energy production. Australia's uranium industry is based on world-leading resource and high and growing annual production. The resources are usually suitable for low-cost production with minimal long-term environmental and social impact. And then Becky will introduce the combination of wind energy and nuclear reactors.
Now let's move to the next part. With the continuous development and progress of society, energy demand will also increase proportionally. The development and utilization of resources in the future will be limited. Therefore, the development of renewable energy is particularly important. Renewable energy is energy that does not deplete or naturally replenish during the human life cycle. For example, wind energy, solar energy, geothermal energy, biomass, hydropower. Next, I will compare the advantages and the disadvantages of nuclear energy and wind energy. As shown in the figure, first of all, nuclear energy is not affected by the weather and the economy, so it can produce enough electricity at low cost. But nuclear energy is not a renewable energy source, so it needs a lot of fossil energy support. In contrast, wind energy is very environmentally friendly, low carbon, high energy source, but it is affected by the weather and the seasons. Moreover, wind and nuclear power has sufficient energy advantages in Australia. The first figure shows that in 2018, Australia's wind farms produced 33.5% of country's clean energy and provided 7.1% of Australia's total electricity. In addition, more than 850 megawatts of wind energy was installed in 2018, the best installed capacity of wind farms in history. The second figure shows that Australia also has the largest uranium reserves in the world, which provides a good conditional basis and support for the development of nuclear energy. Therefore, the combination of nuclear energy and wind energy is particularly important and critical.
The purpose of establishing the virtual power plant is to make the power of renewable energy power plants closer to non-renewable energy power plants. Due to the instability of wind power generation, such as no wind or mechanical failure, small nuclear reactors are needed to supplement the lack of capacity of wind power plants. The output power of a renewable combined power station is more stable at around 900 million watt. The advantage of this combination is that the location of the nuclear power plant construction is superior compared to another combinations of wind energy. Nuclear reactor cooling requires plenty of water, so nuclear power plants are usually built near the ocean, and sea breeze is also a favorite resource for wind power plants. Virtual power plant build a node around the nuclear power plant and deliver electricity to there. Then a cross-shared capacity transmission line to transmission grid. In this process, the need for transportation is reduced, where the power loss caused by long-distance transportation of electricity is avoided because both power stations are built in coastal areas. Economically, the demand for energy in human resources will increase sharply in the future, but the supply of fossil fuels is limited. The cost of fossil fuels in the future is uncontrollable. The nuclear for uranium of nuclear reactors produce electricity requires a little amount and does not produce greenhouse gas, carbon dioxide at the same time, which does not cause a global warming, causes more vicious circles of energy that humans need to cool down, and uranium reserves are sufficient and now known as nuclear force with no other functions. The supply of energy may be subject to various restrictions. For example, knowing dams has established hydronic systems, large-scale shortages, but energy engineering relies heavily on environment, energy security, fuel price fluctuations, and carbon dioxide limits. Establishing more virtual power plants can reduce the pressure on energy demand for traditional chemical power stations. As a clean energy resource, the virtual power plants have one renewable energy credits for sale every 1 kilowatt hour, which can be used as virtual power plants income.
The Diamond Framework is a structured model for analyzing and guiding projects in four aspects: novelty, technology, complexity, and pace, and also can be used for risk identification and risk management. It allows project managers to determine the disparity between the actual state of the project and the state it should be reached, hence to evaluate the relative measures to make the projects on the right track. The first base of Diamond Framework is novelty, which is aimed to bring innovations to the project. Innovations in different aspects of the project often bring various opportunities and benefits to the project. In energy program, the combination of wind energy and nuclear energy can not only reduce the impact of nuclear energy on the environment due to the sustainability of wind power. Increasing the use of wind energy can also extend the service life of nuclear energy. The second base is technology. The mix of new and mature technologies will always bring a lot of uncertainty, such as insufficient basic power supply due to lower energy production of the wind power system. It should be well controlled based on the existing knowledge of the project team and the selection of technical team. The next base of Diamond Framework is complexity. The complexity base measures the three different types of complexity within a project and assesses how they are organized, which are assembly, system, and area. The assembly is to determine the complexity of material net used in energy program from lowest degree to highest degree of complexity. System is about providing information on the manufacturing complexity of energy program, and the area is to arrange multiple systems refer to the attributes of the stakeholders. The last base is pace, which is the management of time-sensitive projects. Although each project should be completed on time, some projects has to be put on the process due to the urgency. For example, the construction material delivery in energy programs. The entire project may not be able to start due to the delay of material. Most of the urgency events are more time-sensitive than others because the failure to meet the project would result in the loss of opportunities and the inability of the project. Therefore, the Project managers in energy programs should develop a series of contingency plans to deal with the emergencies.